Hi, on this practice number 4, we are going to analyze the aluminum 6061 and the 1018 steel. We are going to use the universal machine in order to calculate the elasticity of these two materials. We are going to calculate some data, and after that we are going to compare them with the ASTM information of the book, and we are going to finally calculate the error percentage between the calculated data and the book information.
I'm out of excuses, I know it was
4140. We got the initial data for length and also the area, and then we got the final data, and these are what we got. And first we calculated the yield strength. We use the force divided by the area, and the force is in this point where it passes to the plastic zone, and we got that is 84,135 psi. Then we got the tensile strength, that it's also the force divided by the area, but in this case the force is where it breaks, so it's a different force, and we got that is 91,000 psi. For the modulus of elasticity, we got it from the graph, and it's right here, and is 44.3 times 10 power to the 6 psi. And for the elongation, we have to divide the final length minus the initial length divided by the initial length, and this multiplied by 100 because we wanted the percentage, and we get that is 19%. And the area reduction, it's the initial area minus the final one divided by the initial one, also multiplied by 100, and we got that is 61.91%. Finally, we calculated the percentage error for the modulus of elasticity, and we got 45.4%. Then we calculated also the error for the yield strength, and we got 39.7. And finally, the error for tensile strength, that is 4.04%.
This is the result for aluminum 6061. We obtained this longitude, the origin, the final, the initial area, and the final area. First, we calculate the yield strength at 0.2%. This is force divided by area. We use this value of force that we obtain here in the table, that is 6,620 pound force. The yield strength was 33,000 psi. Also, we calculated the tensile strength, that is force divided by area. We use the force that we obtained here in the table. The result was 55,000. And next, we calculate the modulus of elasticity, that is stress divided by strain. This value was in the graph was 70.45 10 power 6 psi. With these numbers, we obtain the elongation in percent, that is the final minus the original divided by the original, multiplied by 100. We obtain 19.27%. The area reduction is the same. The initial area minus the final area divided by initial, that is 47.08%. The percentage of error of the modulus of elasticity was 24.5%. This was too big because when we use the machine, we move the material, so the graph was a little bit strange. With this value of the error we obtain in tables, also the percentage of error of the yield strength was obtained in tables, so was 8.47% and the tensile percentage of error was 7.22%.
Results that we obtain during the practice, we can determine that the steel is a more ductile material comparing it with the aluminum. Why? Because the yield strength is bigger than the aluminum yield strength. That means that the steel holds and resists more stress before passing to plastic deformation. Table we can observe that this red line is the elastic limit. Here this zone is the elastic zone and this one is the plastic zone. We can determine the yield strength starting in 0.2%. Why? Because this is too small. So this is parallel to the elastic limit. Here is the point where the material passes from elastic to a plastic deformation, and this is the breaking zone.
Real conclusion, because we need to do at least 30 proofs like this. We have to take all the standard deviations from all the data and media for taking all the real values. The modulus of elasticity in the aluminum, we can notice that it's a very high number because the extensometer, we have like a manipulation when we are making the test, so we have like a big percentage of error there because all the data was wrong. But all the other numbers we are taken from the original graphic.
Now we are going to know where it's very important to know the tensile strength. When we talk about yield strength, we only talk about plastic deformation. But when we talk about the tensile strength, we are talking about breaking a piece. So it is very important to know the limit of our material because it can break. It can tell us when it's going to break the system. Because if a piece breaks, all the system breaks. I think it's very important to know the characteristics of a metal to predict when it's going to break and how it's going to develop in the industry. Also, I think the universal machine is very important for this analysis. And
I think that this practice was very important because we learned to analyze different materials and know which one is going to last longer and which going to last longer, and also which to analyze how the material works if you want some exact properties.
This practice is very important to know how to calculate the properties of each material. So our design that we do in computer and we try to make it real function as its purpose as we want to function for a specific thing.
Practice was really interesting because we could see where the plastic point or the plastic zone is, and this is the point where the material starts to deformate and never goes back to the initial state. And also we could see the tensile, where the tensile strength is, and it is where the material completely breaks. And it's really important to know because this can cause like really important problems in the mechanisms or in the machines or in where we apply the material.
After finishing this practice, I would like to do another time the tensile test in the aluminum bar because I have the doubt that what are the exact values or the exact data, and that's all.